So second part is an association rule mining. So under this, these are the terms: market basket analysis, frequent item rates, closed item set, and association rule mining, multi-level association rule, constraint-based association rule, a priori, and frequent pattern growth algorithm. So we'll start with this topic. So first, what is frequent pattern analysis? It's in a frequent patterns are what? It's a pattern which occurs to frequently. Okay. So pattern is what? It's a set of items, subsequences, substructures. That is the pattern that occurs frequently in the data set. So the finding inherent regularities in the data, that what products often purchase together. Okay, what a person will buy after buying a particular product, and what kind of DNAs are sensitive to this new drug. And again, can be classified in various areas. We can apply this, finding the frequent pattern analysis. Applications are majorly basket analysis, cross marketing, catalog design, sale campaign analysis, web log analysis, and the DNA sequence analysis. So why it is important? It's because it's used the foundation for many of the essential data mining tasks like association, correlation, causality, sequential or structural pattern analysis on various kind of data like spatio-temporal data, multimedia data, time series data, stream data. Classic. It's also that is foundation for classification, clustering, for data warehousing, semantic data compressions, and has very broad application actually. So we'll go with the basic concept with respect to this frequent patterns. So example, that is a data set with the 5 items, 5 transaction IDs and item plot is enlisted in this table. Now item set is what? A set of one or more items, and k item sets, that is the k number of items in a set. That is what k item set. K number of items in a set. Then two important terms, that is support and confidence. So support or absolute support. Support count of x is what actually frequency or occurrence of an item set x. Number of times a particular item set occurs, particular item occurs, okay, in a transaction, that will be what the support count of that. So relative support is what? S is the fraction of transactions that contains x. Fraction of transactions that contain x. That is the probability that a transaction contains x is what relative support. Probability that particular item will contain in a transaction. Now, just as an example, relative support is what? Total 5 transactions are there. In that, butter occurs 1, 2, 3, 3 times, right? So 3 by 5 will be what? The relative support. That is the probability that transaction contains the x. 3 by 5. An item set x is a frequent if x support is now less than a minimum support threshold. So while dealing with this problem, we are setting that the user is going to set a minimum support threshold. Minimum support threshold. That minimum support should be what? Now within this, there are total 5 transactions. If we say minimum support is 2, means at least 2 times that particular item will should appear in the given data set. So find all the rules, that is x tends to y with the minimum support and the confidence. So support is a probability that a transaction contains x and y. Now we are extending that is with the 2 item set. 2 item set, that is x tends to y. So x, if x is present in the particular transaction, then y should also be present. So together it is what? X union y. So both will be there. That is the probability is the support. Probability that a transaction contains the atom x as well as atom y. And confidence is what? It's a conditional probability that a transaction having x also contains the y. Transaction having x also contains the y. So let's say minimum support is equal to 50% and minimum confidence equal to 50%. So frequent pattern, that is butter equal to 3. nuts 3, diaper 4, egg 4. So that is what the total number of times that particular atom appears in our data set. So butter occurs 3 times, 1, 2, 3. Nuts 1, 2, 3. Likewise, diaper is 4 times occur in the data set, 1, 2, 3, and 4. Right. So that is what actually a not a support actually. Now butter and diaper support count is what actually support count is 3. That butter and diaper together will be there 3 times. Butter diaper 1, butter diaper 2, butter and diaper 3. Right? Out of these 5 transactions. So that is frequency is in a 3. So support is what? The probability that a transaction contains atoms X union Y, and conditional probability, that is confidence that the transactions having X also contains the Y. Having X also contains the Y. So scalable frequent atom set mining methods. So two methods that are under this association rule mining. First is a priori, that is a candidate generation and test approach. Second is frequent pattern growth approach. Now, this frequent pattern growth is what that is in improving to the a priori resulted to the FP growth algorithm, frequent pattern growth. That we are minimizing the number of computations, number of comparison in a priori, and that leads to a solution given. That is another algorithm, frequent pattern growth algorithm. What are the disadvantages was there or improving the efficiency of a priori? It leading with the next, that is the FP growth. So basic concept of association rule mining is finding the frequent pattern, association, correlation, or causal structures among the set of the atoms, objects and transaction databases, relational databases, and other information repositories. So applications, basket data analysis, cross marketing, catalog design, clustering, and classification. Based on our problem statement, the patterns, we can classify it, we can cluster it, right? We can do market basket analysis for improving the business, right? Cross marketing, that is keeping the frequently purchased items together in a shelf. Catalog design, that is the frequently purchased together items having their description in the catalog nearby to each other. Okay. Examples of this association rule mining, that is body tends to head, means if body is there then head is there with respect to support and with respect to the confidence, right? Support is what that this both will be together, body and head. Okay. And confidence is that body will be the head will be there provided that body will be there. Okay. That is the confidence. Association model problem statement. So capital I represented for the set of atoms where I1, small I1, I2, In, these are the atoms. Okay. And capital I is the set of atoms. J equal to P of I, the set of all subset of the set of atoms. Elements of J are called the atom sets. Now power set of I, that is power set of I, all possible subset of the set I. That is what our J. J are is also called, J is called the atom sets. T is the transaction, T is a subset of I. Total items, whatever there in the shop, and that particular transaction with the having some subset of this I, having some of the atom sets, atoms in its set. Database, a set of transactions. And an association rule mining is an implication of the form X tends to Y, where X and Y are disjoint subset of I. This X and Y is not an atom, it's a subset of atom. It's a set, or obviously it's a subset of the atoms. So for our case, X and Y are the subsets. So where X and Y, that subset is non-empty subset, right? And it should non-empty means it should contain at least one of the atom. X tends to Y are disjoint subset of the I element. A problem is find a rule that have support and confidence greater than the user specified minimum support and the confidence.
I
So support and confidence, an example. So a data set is given with the transaction ID, 4 transaction IDs are there, and the items plot. So confidence, conditional probability that a transaction having X also contains Y. So for this, let's minimum support is 50% and minimum confidence is 50%. Then we have A tends to C. Now these are the items, capital A and capital C. A tends to C is a rule, right? If A then C, you can read this as with the support is 50% and confidence is 66.6%. Now how this 50% comes? There are total 4 transactions, right? Total 4 transactions are there. Within that, A and C, that A union C is occurs 50% of the time. If you observe the transaction ID 2000 A and C, transaction ID 1000 A and C. So out of 4, 2 are with the A and C. So the support is 50%. Okay. Now we'll go on directly second example with respect to support. C tends to A. That if C then A, that is C union A is also 50% support. So if you'll observe that CA, right? So out of 4 transactions, 2 are with the C and A. So the support is 50%. Now we'll see the confidence. So for A, then C, confidence is 66.6%. So the definition of confidence, that is conditional probability that a transaction having X also contains the Y. So here X is A and Y is C. Transaction having X also contains the Y. So there are total 4 items, right? And A also contains the C. So out of this, if you observe the A and A, 3 times A appears, right? So out of this 4, so it is 66.6%. That 3 times it's together actually. 3 times means A and C. A and C is here and A is there. So 33%, 33%. In total, out of 4 transactions, A is in the 3 transactions. So skip this last transaction for our case to calculate this confidence, right? So out of these 3, A and C will be A, provided that having also contains the C. So out of this first 3, this will be 33.33, this will be 33.33. So the confidence is 66.66. Now for second case, C then A. In C then A, there will be a confidence conditional probability, that is the having X also contains the Y. So C also contains the Y. So wherever is the C, there is an A. So there is a 2 transaction with respect to that where the C and A is appears. So that is the confidence is 100%. So a priori algorithm is an important algorithm, initial algorithm for mining frequent atom sets for Boolean association group. So key concept, 3 important terms are there with respect to a priori algorithm. First is frequent atom set. The set of atoms which has the minimum support denoted by L suffix I for the ith atom set. Frequent atom set, the set of atoms which has the minimum support denoted by Li. A priori property, that is any subset of frequent atom set must be frequent. A priori property, very much important priority because this is the core of this a priori algorithm. Any subset of a frequent atom set must be frequent. We'll see that in next slide with the example. Next is join operation. Now to find Lk, a set of candidate k atom set is generated by joining Lk minus 1 with itself. So let's say suppose that is if you want to compute the join operation for capital L2, then we need to have join operation of L1 join with the L1 join with the L1 for L2 is equal to L2, L3 equal to what? That is L2 join with the L2. So frequent items, sets, a priori, property, and the join operation. Now, a priori algorithm. Find the frequent item sets, the set of items that have the minimum support. So that minimum support, it's in a threshold that is given by the user. A subset of frequent item set must also be frequent. That is the a priori property. So example, let that is if A B, uh, obviously A comma B will be there. So a set with the two items A and B is a frequent item set. Both A and B should be frequent item set. So this particular set, atom set A comma B is a frequent if and only if both this individual A atom, B atom, that also should be frequent atom set. Means that whatever the support threshold is given, it should satisfy with respect to this individual atoms also, right? Then only they are become a frequent atom set with this minimum support. So if minimum support is individually is threshold is crossing, means having whatever the threshold is given more than that value with respect to the particular atom, so their set means their combination is also satisfies this minimum threshold condition. So that is what the a priori property, that A comma B is a frequent item set provided that both A and B should be a frequent item set. So iteratively find frequent item set with cardinality from 1 to k item set. Use the frequent items together to generate the association rules. Now, algorithm. So first, that is join step. CK is a candidate item set. The CK is termed as a candidate item set of size k, is generated by joining LK minus with itself. LK is what? It's a frequent item of size k. So to compute C1, let's say k equal to 2, let's say for example, C2, we need to join L1 with L1, L1 with the L1 for k equal to value 2. Likewise for C3, to compute the C3, we need to join L2 with the L2. Next print step. In print step, any k minus 1 atom set that is not a frequent cannot be a subset of frequent k atom set. Print step is what? Any k minus 1 atom set that is not frequent cannot be a subset of frequent k atom set. So it should satisfy that minimum threshold, whatever is the set. So which particular subset or sequence is not following this minimum threshold, that we are removing from this, that is termed as a print step. Right? Print step is other, that is dictionary meaning for print is what? That is cropping, cutting. Right? So whatever the atoms not following minimum threshold, we are removing that. That is what the print step. So pseudocode, that is CK and LK. L1, that is the frequent items. That is you can say L1 is what? That is an individual atoms, right? L1 is individual atom. L2 is what? Join of L1 L1. For L1 join of L0 L0, no atoms are there, right? So L1 is what? Frequent individual atoms. For k equal to 1, Lk is not equal to 5, that it should be a non-empty set, right? K plus plus to begin. Ck plus 1 candidate generated from Lk, that is a joining operation. For each transaction T in database, do increment the count of all candidates in C k plus 1 that are contained in capital T. Lk plus 1 is equal to candidate in C k plus 1 with minimum support. L return this Lk, that is an union of k for all atoms. So tell this that we are executing this till Lk is 5. When it becomes 5, then we come out of this loop. Now we'll go through this understanding by an example. So a priori example. So data set with the 9 transactions, transaction ID, and the list of items. I1 to I5, these are the items. So transaction 1 contains this 3 items likewise. Transaction 900 contains 1 to 3 items. So data set with the 9 transaction, and we have set the minimum support count as an 2. Okay. So minimum support equal to 2 by 9. So total 9 transactions are there, and we have taken count as an 2 minimum support count. So that becomes 22% is our support. And let we have set the minimum confidence required, that is the 70% is the threshold value for the confidence we kept. These are the user defined value, minimum support and minimum confidence. So we have to find out the frequent item set using a priori algorithm. Then association rule will be generated using minimum support and the minimum confidence. So first step, that generating one item set frequent patterns. So scan capital D for a count of each candidate. So total 5 item set was there, 1, 2, 3, 4, 5. So in our data set with the 9 transaction, I1 occurs total number of 6 times, I2 occurs 7 times, I3 6, I4 2, and I5 2 times occurs in a data set. This will cross check that with respect to I5. So I5 appears here, count becomes 1. Then it appears at the transaction 800, it becomes 2. Okay, so 100 and 800 only I5 appears. So the support count for I5 is equal to number of time it occurs, that is 2. So this is support count, 6 time appears, 7 time appears in this way. And minimum support that we have taken count as an 2. So this all satisfies this condition which is imposed as an threshold value of support count. So first iteration of the algorithm, each atom is a member of the set of candidates because as it satisfies this. Now compare candidate support counts with the minimum support counts. So it all satisfies, so that is become our L1. Right? So the set of frequent one atom set L1 consisting of the candidate one atom set satisfying the minimum support. So all atoms are satisfying. Now generating two atom set frequent pattern, that is C2. C2 is computed by L1 join with the L1. Okay. L1 we are having in our previous slide. This is our L1. So L1 join with itself, that becomes the C2, right? So generate C2 candidate from the L1. So this is the result of this join operation. Okay. So how this join operation will be done, that is like this. That is I1 join with the 2, 3, 4, 5. I2 join with the 3, 4, 5. I3 will be get joined with the 4 and 5, and I4 join with the I5. This is the join operation. So that resulted into I1 with the 2, 3, 4, 5, 2 with the 3, 4, 5, 3 with the 4, 5, and 4 with the 5. So this is the generation of C2 by joining L1 with the L1. Now scan D for the count of each candidate. Now with respect to our transaction, that is data set, counting this number of times that together I1 and I2 appears in the data set. So it appears 4 times. Likewise, I1 and I3 appears 4 times. So this table is prepared in this way, that is counting of the support, number of times that togetherly occur in the data set. So as we know that minimum support count is 2. So we have discarded those who are having minimum support count less than 2. So greater than or equal to 2 is our minimum support count. So that leads to the L2.